Okay, so we are in 11.6, recursion and special sequences. Here are the page numbers to tell you where to go. So we start with the Fibonacci sequence. This is our first recursive sequence we're going to look at. It goes 1, 1, 2, 3, 5, 8, 13, 21, and so on. How do we get the Fibonacci sequence? We have this right here, tells us how to get our next term. What you do is each new term takes the sum of the first two terms, or the previous two terms. So 1 and 1, they give us those, and then 2 is 1 plus 1. 3 is 1 plus 2. 5 is 2 plus 3. 8 is 3 plus 5, and so on. Okay? So a recursive formula, each term is formulated from one or more previous terms. Okay? And we see the Fibonacci sequence here. an, right? So whatever your nth term is equal to an minus 2 plus an minus 1. Okay? That's one of our special Fibonacci sequences. You actually see it a lot in nature, so that's why we use it. Okay? So we're going to use a recursive formula. This is example 1. This is page 658. First, find the first 5 terms for this sequence. They tell us our formula. Okay, to find n plus 1, we take 2 times an plus 4. Okay, they tell us our a1, and then they tell us for n greater than or equal to 1. So our a1 is negative 1. To find our next term, okay, to find this term, you take the previous term, multiply it by 2, and you add 4. Okay? So negative 1 times 2, or actually, I'm just going to write this whole thing out. 2 times negative 1 plus 4 equals 2 times negative 1 is negative 2 plus 4, which equals 2. All right, now, this next one, we take our previous term. We are going to multiply it by 2. Okay? 2 times our previous term plus 4. 2 times 2 is 4, plus 4 is 8. 2 times our previous term plus 4. 2 times 8 is 16, plus 4 is 20. 2 times our previous term plus 4. 2 times 20 is 40, plus 4 is 44. All right? So that's how we use a recursive formula. Okay? Each new term in our sequence uses at least one previous term and does something to it. In this case, it was 2 times our previous term, and then we add 4. Okay? Let's look at example number 2. Page 659, finding and using a recursive formula. This is example 2. Okay, so they went through an example with a bacteria and a certain dose of medication. Okay, and then they give us, okay, but what if the dose of medication kills this many bacteria instead of the previous? And so it's the exact same setup. We are just defining it for a new type of a new type of medication. Okay. So here we're going to let Bn equal the bacteria alive before the dose of the drug. So Bn minus however many of our bacteria is killed by our dose of our drug equals the bacteria after dose of drug. And we know that the bacteria, after we give a dose of the drug, they increase, however many are left, increases 50%. So that's 1.5 times the bacteria alive after the dose of drug to get our final value. And then we can simplify this out. 1.5 times Bn, 1.5 times 6.0. This should be a 9.0 times 10 to the 8, but that's okay. Okay, so this is our new formula. This is how we find it. All right. For what n will b of n plus 1 be less than or equal to 0? Okay, so this question is asking us, how many doses of the drug do we need to take before our number of bacteria is 0? All right, we're going to want to have a calculator so that we don't have to try and do this all in our head. We're going to have to do some of it in our head. So how do we get this? Well, we take 1.5 times our previous term, and then we subtract this. So this is going to be 1.5 times 1.0x 10 to the 9 minus 9.0 times 10 to the 8. Okay, so 1.5, so this is going to end up being 1.5 times 10 to the 9 minus 9.0 times 10 to the 8. All right, we can plug this into a calculator. Okay, and what you can do, right, if you are like, how am I even going to plug this into a calculator? Okay, we can get the same type of notation. We say, okay, well, this is really 15 times 10 to the 8 minus 9.0 times 10 to the 8. What's 15 minus 9? Okay, and it's going to be times, I believe it would still be times 10 to the 8, but let's, well, yes, it would be, here's the proof of that, 10 to the 8, 15 minus 9, right? We just factor out 10 to the 8, okay? So that's something we can totally do. This is going to end up being 6 times 10 to the 8. So that is our B2. Now we're going to do our B3, okay? So we want 1.5 times 6.0 times 10 to the 8 minus 9.0 times 10 to the 8. All right, I'm going to need to go under here. 1.5 times 6.0 is 9. Okay, yep. Just checking my arithmetic on my calculator because I don't want to make mistakes. 9.0 times 10 to the 8 minus 9.0 times 10 to the 8, which is equal to 0. A number minus itself is equal to 0. So the answer to the question, for what value of n will our term be less than or equal to 0? So what it's asking is, after how many doses of our drug will the bacteria be 0? Our bacteria will be 0 after 3 doses. Okay? Our bacteria will be 0 after 3 doses. All right. So iterate a function, example 3, page 660. So iteration is composing a function with itself repeatedly. So given a function f of x, okay, this is f composed with f of x, is f of x, okay? F composed f of x equals f of x, okay, and so on. So we are creating a recursive formula, okay? So iteration to recursively generate a sequence x naught, or x to x0, right? We call it x naught usually, equals the initial value and a function f. So if we are given an initial value and we are given a function f, x1 is equal to f of x naught, x2 is equal to f of x naught, otherwise known as f of x1, x3 is f of x naught, which is also equal to f of x2, okay? So that's what we do. So here, we're going to find iterates for x1, x2, x3, and x4. For this function, f of x equals x squared minus 2x minus 1, and x naught equals negative 1. So the first thing we need to do is we need to find x1. How do we find x1? We just plug in our initial value to our function. Oh, you could probably actually see it up on the screen. So x naught is negative 1. x1 is negative 1 squared minus 2 times negative 1 minus 1, which equals negative 1 squared is 1. Negative 2 times negative 1 is 2 minus 1. So this is equal to 2. Okay? Our x2, we take this value and we plug it back into our original function. 2 squared minus 2 times 2 minus 1. 2 squared is 4 minus 2 squared is 4 minus 1. So this equals negative 1. Plugging our negative 1 back in, negative 1 minus 2 times negative 1 minus 1. Oh, negative 1 squared. So this gives us 1 plus 2 minus 1, which equals 2. Plugging our x3 in to find our x4. 2 squared minus 2 times 2 minus 1 equals 4 minus 4 minus 1, which equals negative 1. All right. I'm going to check that that is correct because it does not... Did I write the problem down correctly? Why am I asking that? Well, because if you get something like this where you have a pattern that you did not expect, always check that you wrote the pattern down correctly, which is what I'm going to do really quickly. Going to the book. Where is it? Oh, this is the wrong chapter. That's why it's not there. Okay, so x squared minus 2x minus 1. Our initial value is negative 1. Negative 1 squared is 1. Okay. Negative 2 times negative 1 is positive 2. Okay, yeah. So assuming I did my arithmetic correctly, which it looks like I did, that is our iteration of a function. All right. All right, go ahead and do the check your understanding. Pause the video, do the check your understanding, and then come back to the video and check your work. So here we are finding the first 5 terms. We are given our first term. We are given our recursive sequence. So what do we do for a term? We take the previous term and we subtract 3. So this is going to be 12 minus 3, which equals 9. This one is going to be 9 minus 3, which equals 6. This one is going to be 6 minus 3, which equals 3. This is going to be 3 minus 3, which equals 0. Okay. Here, what do we do? Well, for each new term, we take our initial, or we take the previous term and we add whatever our term value is. Okay. So here, A2 equals A1 plus 1. Okay. So A1 is negative 3 plus 1, because that's our n value, which equals negative 2. We take negative 2 plus our n value, which is 2, which equals 0. So we have 0 plus our n value, which is 3, which equals 3. We have 3 plus our n value, which is 4. So that is equal to 7. All right. That's that recursive formula. Now here we have this formula here. What do? We multiply our previous term by negative 2, then we subtract 4. So here we have 0. So negative 2 times 0 minus 4. Negative 2 times 0 is 0, so this is going to be negative 4. We have negative 2 times negative 4, and then minus 4. Negative 2 times negative 4 is positive 8, minus 4 is 4. Negative 2 times 4 minus 4. Negative 2 times 4 is negative 8, minus 4 is negative 12. Negative 2 times negative 12, and then minus 4. Negative 2 times negative 12 is 24, minus 4 is 20. All right. We have our first value, our second value, and then we have our recursive formula here where we take the, let's see, so for a term, we take the previous term and multiply it by 4, and then we take the second previous term and multiply it by 3, and we subtract. Okay, so here A3, that's my alarm. Sorry about that. So here, A3, okay, A3 equals 4 times A2 minus 3A1. So 4 times A2 minus 3 times A1. 4 times 2 is 8, minus 3 times 1 is 3. So 8 minus 3 is 5. Now A4 is going to be 4 times A3 minus 3 times A2. 4 times 5 is 20, 3 times 2 is 6, so 20 minus 6 is 14. 4 times, so A5 is going to be 4 times A4 minus 3 times A3. 4 times 14 is 56, I believe, but I can always just check with a calculator. 56. 3 times 5 is 15, so this can be 56 minus 15, which is, I almost wrote 14, it's 41. Okay, that's our iteration, or not our iteration, that's our check your understanding 1 to 4. All right, now here, Rita deposited $1,000. At the end of the year, we add 3% and then we subtract $10. Okay, so B0 is $1,000. We're going to find Bn for n years. Does that make sense? That B, yeah, because at the end of the first year, that's so. Before a year has passed, this was our initial deposit, I believe. Yeah, yeah. That's so. This is B0 because this is the initial deposit, and then Bn for n years. So it's after how many years? But if no years have passed, that's 1,000. That's where that came from. Okay, so we know that Bn is the value for if Bn is after n years, Bn minus 1. So Bn minus 1 is equal to balance at start of year. Okay, so Bn minus 1 is the balance at the start of the year. So then we say, okay, well, what do we do to Bn minus 1? We add 3%, so 1.03 times Bn minus 1, and then we subtract $10. And this is balance at end of year. What does that mean? That means that Bn equals 1.03 Bn minus 1 minus 10. Okay? Probably, it is entirely possible that if you wrote it differently, you might have gotten Bn plus 1 equals 1.03 times Bn minus 10. Okay? These will give you the exact same values if you define your starting place clearly. For mine, I determined my starting place as the 0, right? So that's where this came from. Okay. All right. Does that make sense? Yeah, because balance at the start of year 1 is 1 minus 1, which is B0. Yeah, okay. So now we want to find the balance at 4 years. Okay, so 4 years have passed. How much money is in our account? So we want B4, which equals B3, B3, but I need to multiply. 1.03 B3 minus 10. Okay. So what we're going to do is we're going to set up, we know our B0, we're going to find B1, B2, B3, and then B4. Okay? And we can use a calculator for this, right? We don't have to rely solely on our brains. It is actually, because we started with $1,000, it is pretty easy. So this is $1,000. Okay? 1.03 times this value here. So that is 1030. So we added $30. Then we're subtracting 10. So that is 1020. Okay. Now at this point, it's a little bit more complicated. So I'm gonna just switch to using a calculator. There's nothing wrong with using a calculator for stuff like this. What it is that I'm typing into my calculator. We're going to turn the brightness down so it actually shows up on camera. There we go. Okay, 1.03 times my previous term, which is 1020, close parentheses, minus our 10, and we get 1040.6. 1.03 times 1040.6, close parentheses, minus 10. We get 1061.8. Because it's money, I'm going to round right there. Well, no, you know what? I'm going to keep it as is. But then I'm also going to do a second one over here where I do round, and I'm going to see if it changes the final answer that we get. Okay, I'm just going to do both. Okay, so 1.03 times 1061.818, close parentheses, minus 10. And we get 1083.67254. And then I'm going to plug this one in as well just to see if it changes. So we made that a 2, and we got rid of that. So we get 1083.6746. So we're going to be rounding to 0.67 for our final answer. So that means it's not going to have affected our answer when we rounded. Okay. But there's nothing wrong with being more precise and then rounding at the final answer. So balance is 1083.67. We're rounding correctly. We added our proper label. All right. Find the first 3 iterates of each function and initial value. So they give us a function, they give us an initial value. Our iterate 1, we plug our initial value into our function. 3 times 3 minus 4. 3 times 3 is 9, minus 4 is 5. 3 times 5 minus 4. 3 times 5 is 15, minus 4 is 11. 3 times 11 minus 4. 3 times 11 is 33, minus 4 is 29. Okay. So here we have negative 2 times our first value plus 5. Negative 2 times 2 is negative 4, plus 5 is 1. Negative 2 times 1 plus 5. Negative 2 times 1 is negative 2, plus 5 is 3. Negative 2 times 3 plus 5. Negative 2 times 3 is negative 1, plus 5 is, negative 2 times 3 is negative 6, plus 5 is negative 1. All right. Here we have negative 1 squared plus 2. Negative 1 squared is 1, plus 2 is 3. 3 squared plus 2. 3 squared is 9, plus 2 is 11. 11 squared plus 2. 11 squared is 121, plus 2 is 123. All right. I believe, yep, that is the end of the check your understanding. There you go. We will have an assignment on this in class.